As much as life has changed over the last year, you're still pretty busy, so consider convenient COVID-19 testing from Quest. Get the same tests hospitals use without a doctor visit. Simply order online, select from drive-thru or at-home options, and get results sent securely to your phone or computer. It's a great fit for your busy life. With over 25 million COVID-19 tests processed, you can count on Quest. So order your test today at questcovid19.com. That's questcovid19.com. With Masterclass, you can learn from the world's best minds anytime, anywhere, at your own pace. Learn how to ace your opponent from Serena. Improve your writing skills with Neil Gaiman. Learn how to negotiate with Chris Voss. All right. Those were the courses I chose, but you'll have over 90 classes to make your own choice, and they're all taught by world-class instructors. Now, of course, the master instructor, Dr. Neil Degrasse Tyson, has a masterclass of his own on scientific thinking and communication, and we all know how important that is in these times. I'm not the only one who's benefiting from my masterclass. My brother is an avid tennis player, and I sent him the gift of a subscription so he could get schooled by Serena. Did I tell him that it was a part of my subscription? Well, let's just say the answer rhymes with ho, ho, ho. From learning how to write anything from a book to a screenplay, to communicating with your boss, to how to make dinner worthy of a Michelin star or just the best scrambled eggs this side of a jumpy chicken, there's a master class for you. I'm in the middle of a course on sex and communication because I'm good at one of those things. Masterclass is accessible on your phone, web, or smart TV. You can get an annual membership to Masterclass and give one to someone else for free. Get unlimited access to every Masterclass for you and a friend right now. Just go to masterclass.com/StarTalkRadio. That's masterclass.com/StarTalkRadio.
Welcome to Star Talk, your place in the universe where science and pop culture collide. Star Talk begins right now. This is Star Talk, Cosmic Queries Edition. We could not resist. The Nobel Prizes in physics are related to black holes. Chuck,
yes.
We're devoting this entire Cosmic Queries to black holes as manifested in the recently announced Nobel Prizes in physics.
And the cool thing about it is no one will ever be able to see or hear this video because it won't be able to escape our black hole.
Oh, is that right? I didn't know that all of our shows are in black holes, Chuck.
Just this one.
I know a little bit about black holes, but not as much as our guest, a recurring guest, Janna Levin. Janna, welcome back to Star Talk.
Thank you. It's always good to be here. Wherever here is now.
I know, but for you, you kind of look like you're in a safe house.
I know. I sort of am.
Yeah, are you in an identity protection program or something? What do you do?
I'm at Pioneer Works, which is, a cultural center in Brooklyn, where I'm director of sciences. But I tell you, if the apocalypse is happening, this is where I'm coming. We've got all the resources you need.
Wait, Chuck, did you hear that? If the apocalypse is coming, that's where she'll be, and that's where she is now.
Right, exactly.
And you're invited.
Okay. So wait, tell me what happens at Pioneer Works.
So we, this place really started as inspiration of Dustin Yellin and Gabriel Florence as an art center, but with a vision of just impacting culture in creative ways, really kind of breaking down boundaries, doing things in a new way. And when I came in, we started bringing sciences in here, and we've been doing a lot of pretty incredible science events, not least interviewing Sir Roger Penrose last December.
Oh my gosh.
Oh my God.
That's why he got the Nobel Prize. That's why he got the Nobel, because you interviewed him.
I just rubbed my good karma on him.
So tell me, I know two of the three Nobel Prize winners, maybe all three. So there's Roger Penrose, a well-known physicist from Oxford, I think, in the UK. We have, who else was on that list?
Andrea Ghez.
Andrea Ghez, and is she still in the University of California?
Yeah,
system?
UCLA.
UCLA. So, and we had Gensler.
Reinhard Genzel, yeah.
Reinhard Genzel. And so they all split the Nobel Prize, all for their work in black holes. So if you can just give us sort of the the short version of each of theirs contribution to our understanding of black holes?
Well, technically, Roger got half the prize. And
Really?
Andrea and Reinhardt split the other half.
So now, when you say got half the prize, are we talking
Half
about
the money.
cold hard
Half
cash?
the money. Half the money.
Wow.
They each get. They don't get a half a medal.
Right.
They all each
They
get the
all
same
get a medal.
But when they say half, they mean half the money.
Yeah, well,
Yeah.
you can, let me tell you something, you can keep your stinking medal.
How much you have the money?
I want that check.
So it's a super interesting prize because that's happened before, where they've divided the prize unequally amongst the three participants. And you can never have more than three winners of the Nobel Prize. So it does reflect the fact that Andrea and Reinhardt, their work is observational, and they're both responsible independently for understanding supermassive black hole at the center of our galaxy. So that's why they shared in the prize, because they both contributed to that particular aspect of the award. Roger Penrose was just off on his own in like 1964.
He's been off on his own forever. He's on his own thing. Yeah.
Right. So that was all Roger. And he is very theoretical. So I'd say one of the most surprising things about this award was that people as theoretical as Roger Penrose, for example, Stephen Hawking, don't usually get awarded the Nobel Prize. And so this was considered, I think a lot of people were kind of chilled and delighted to see Sir Roger honored in this way.
But it could be that the trend is not so much that they don't give it to theorists, but if they're going to give it to theorists, in the same breath, they're going to give it to the experimentalist who verified what the theorist said. Is that a fair way to characterize
That is a fair way to characterize it. But there's still a long stretch between like Roger's theory and the observations. So if you want to talk about Roger's...
As was true with the Higgs boson.
That's right.
So they gave it to Peter Higgs.
Higgs himself.
Yeah, but he'd come up with that decades ago.
Yeah.
Whereas the fresh discovery of the Higgs boson was in recent news, but they stapled them together and then they give him the award. Yeah.
Yeah, that's right. I mean, Higgs's prediction was so very specific, though. He literally predicted there would be this one particle, it would be roughly around this mass, and it would have these particular properties. I mean, it is a pretty spot-on prediction, whereas Roger just sort of was dreaming big dreams. Not to put Higgs down in any way, but, there was a less specificity. And even when Einstein got the Nobel Prize, he got it for very specific things. He did not get the Nobel Prize for general relativity, which was clearly his greatest achievement. He got it for more specific statements and more specific predictions.
So maybe the Nobel Committee is coming along.
Yeah, maybe it's coming along. But Roger did do something tremendous, which was to make generic the prediction that black holes would be the end state of the collapse of a star. And he was able to show that essentially singularities, which we thought were this maybe an artifact of very special circumstances and wouldn't really happen if you thought more generally about things. He was able to prove that, in fact, it was a generic prediction of general relativity, that a collapsing star would create behind it an event horizon, and interior it would create a singularity, essentially.
Wow.
So it's right after Einstein first thinks of general relativity that Schwarzschild writes to him from the Russian front and discovers this thing that we now call a black hole. But it's
Russian front in the First World War.
In the First World War, it's 1916, and he's on the Russian front, and he's saying, the war has treated me kindly enough, and I've been able to wander through the land of your ideas. And so here he solves this problem, and it's very idealized. It's a complete sphere. It's perfectly collapsed. He doesn't ask how or why. He just idealizes a situation, and he comes up with this thing that we now call a black hole. And so for decades after that, people thought, well, that's just a silly, idealized situation. It's not wrong. It's correct mathematically, but that'll never happen in nature. What Roger Penrose does in 1964 is he uses the most ingenious methods in a paper about 3 pages long. In the final paragraph of this incredibly clear, lucid, simple paper, he proves that, in fact, it is absolutely generic prediction of general relativity that a collapsing body would create behind it an event horizon and inside a singularity. So he makes black holes inevitable.
He made them real.
He made them real.
Made them real.
Wow.
Yeah. Yeah, so they go from this mathematical perfect, silly, platonic idealization to an inevitable reality.
So, and now on the other side of that Nobel Prize coin, we have two people, independent researchers, who are figuring out that our galaxy has a supermassive black hole in the middle. But of course, you can't see black holes. So what light can you shed on their discoveries?
I see what you did there.
You see what I did there?
I see what you did there.
You punster. So they demonstrated the opposite characteristics as powerful scientists. Slow and methodical. They looked at these stars for decades, right? 2 decades. And they watched these stars orbit an invisible object. And they don't even need to...
At the center of the galaxy.
At the center of the galaxy. It's 26,000 light years away in the direction of the constellation Sagittarius. So we call the object that they orbit Sag A star, Sagittarius A star, because it's in that direction from our point of view. It's a cute little nickname. So around Sag A star, they see some stars orbiting, and they can follow their entire orbits. One of them takes about 16, 17 years. That's kind of the one that was most helpful to them.
But just to be clear, normally when we think of things orbiting other things, we think of planets orbiting stars.
Yeah.
Now you're talking about stars orbiting other things.
Yeah. Exactly. Right. Exactly. Mm-hmm. So now you have a bunch of stars in the center of the galaxy, a bunch that are orbiting this thing. Now you can't see this thing. It's definitely dark. And it's very massive. And contrary, I think, to sort of the popular imagination about black holes aren't huge. The whole point of black holes is that they're tiny. So for how heavy they are, they're tiny. So this object, they just look at the orbit and deduce, wow, that thing is 4 million times the mass of the sun. But it's fitting in a region much smaller than the solar system. Not 4 million times the size of the sun, right? If you calculate how big you think it should be, it's about 17 times the width of the sun across, but 4 million times its mass.
That's crazy.
Crazy.
So they go, look, it's really heavy, it's really small, it's a supermassive black hole.
Wow.
Okay. Yeah. Well, there you have it. And by the way, this is our second or third hour, the astrophysics community, our second or third Nobel Prize in a decade. Generally, they used to throw us a bone once every 10 years.
Are you saying that you guys are the Meryl Streep of the Nobel Prize?
No, I'm saying.
Black holes are.
Well, the prize is in the category of physics, just to be clear. So we in my community, we're not living our lives wondering if we'll be considered. Occasionally, we do something that touches on laws of physics, and then it gets, and people take a note. So we just got it for exoplanets, which is not itself a new branch of physics, but it's a very interesting advance in our understanding of the world and or the universe. So I'm just saying, maybe we're done with laboratories on Earth, and the best laboratories on the frontier of discovery are the universe itself.
Well, it's fascinating because Hubble lobbied for astrophysics to be considered by the Physics Nobel Prize.
Hubble the man.
Edwin Hubble, the man.
Not the telescope.
The telescope, is not live. Right, the telescope.
It's not lobbying.
That'd be awesome.
Remains inanimate. Yeah.
Yes, it remains. It's still to this day not alive.
Right, but Hubble, So what did Hubble do that was so tremendous? Today, Hubble absolutely, unquestionably would have won the Nobel Prize. So what did Hubble do?
Two Nobel Prizes.
Right. So for one, in
the same decade. Yes.
Yeah, he realizes that there are other galaxies. You have to realize when Einstein was working in 1905 and 1915 and 1916, he did not know that there was another galaxy besides the Milky Way. He suspected, but he wasn't sure, right? So Hubble observes the first external galaxies.
But just to be clear, at that time, the universe was just the stars of the night sky.
Yeah.
And how far do they extend? Nobody knows.
Yeah. Exactly. And then the second thing, which I'm sure, I'm guessing Neil's referring to, is he then also notices that, oh, by the way, all those galaxies are moving away from each other.
Right.
And so he deduces that the universe is expanding. So
cool. So he lobbied the Nobel Committee, and then what'd they say? I guess they said no.
I don't know if there were formal letters exchanged, but there was certainly political, there was internal politics. And they said no for, when was that, 1920s? They said no for another 50 years. I don't think it was until the 70s that the Nobel Prize Committee considered astrophysics.
Yeah, I think the first one was maybe the discovery of pulsars.
Yeah.
And that was the 1970s on a discovery made in the 60s. Yeah.
Yeah.
Yeah. Cool.
Yeah.
Well, actually, we got to take a break now. But Chuck, did you load up questions? Because this is a Cosmic Queries.
I got them all loaded up and ready to go, and there are pages of them. People love black holes.
All right, when we come back, more with our friend Janna Levin to get us through an understanding of black holes on Star Talk.
Exploring the secrets of the cosmos is a fascinating pursuit, but have you discovered the vast and incredible potential of your own mind? Introducing Advanced Nootropic Formula from V-Thrive, the Vitamin Shop brand. Available at vitaminshop.com or your local Vitamin Shop store. This stimulant-free formula supports cognitive function, neuron development and repair, and brain-derived nootropic factor to promote the survival of existing neurons and encourage growth of new synapses. Non-GMO Advanced Nootropic Formula features clinically studied ingredients like Synapsa for peak cognitive performance, Cognizant for mental energy, focus, and attention, and clinically proven in extras so you can stay extra sharp. In fact, you may experience an improvement in alertness for up to 5 hours. As always, all V-Thrive, the Vitamin Shop brand products, are simply clean with no magnesium, stearate, stearic acid, or titanium dioxide. Advanced Nootropic Formula comes with a quality promise you can trust with ingredient purity and potency verified by independent third-party labs. The best part? It's on sale. Save 15% on purchases of $40 or more when you use code STARTALK at vitaminshop.com today. Again, that's 15% off purchases of $40 or more with code STARTALK on vitaminshop, SHOPPE.com to expand your mental universe today. Are you always taking care of your family? Do you often take care of others and not yourself? Well, now's the time to take care of yourself because you deserve it. Teladoc gives you access to licensed therapists to help you get back to feeling your best, to feeling like yourself again. Sometimes we don't know how much we need to talk to somebody. Take it from me personally. During the entire pandemic, I have had virtual sessions, and it has been such an incredible help. Now, with Teladoc, you can speak to a licensed therapist by phone or video. Therapy appointments are available 7 days a week from 7 a.m. to 9 p.m. local time. Hey, maybe you're feeling overwhelmed. Maybe you feel stressed or anxious or depressed or lonely, or you might be struggling with a family issue. Teladoc can help. No need to wait months to get a therapist. Teladoc is committed to facilitating great therapeutic matches so they make it easy to change counselors if needed for free. Teladoc therapy is available through most insurance or employers, and individual plans are also available. Download the app or visit teladoc.com/StarTalk today to get started. TELADOC.com/StarTalk.
We're back. Star Talk, Cosmic Queries, Black Hole Edition. Actually, Chuck, we've had other black hole editions of Cosmic Queries, but this time black holes upped and won Nobel Prizes. In fact, it's not the first time black holes have won Nobel Prizes. And last time we did that, we had to bring in Janna Levin to explain what the hell was going on, and we're doing that again today in this second segment of Cosmic Queries. Janna, always great to have you back in the loop.
Thank you so much. I always love being here.
One of the times we brought you in was because of the LIGO discovery of colliding black holes.
Right.
And they got a Nobel Prize. Okay.
Yeah.
So black holes so the Nobel committee's likened them some black holes lately.
Yeah, definitely. I think there's probably another one in the near future. Yeah, I mean, I don't want to, I don't know, jinx anything.
Don't jinx them, but don't keep us in suspense either.
Well, I think we should talk about LIGO, but I think Event Horizon Telescope, which took that image of the black hole at the center of M87, which is a galaxy 55 million light years away, and they imaged as close to the event horizon as is essentially conceivable given the realities of where
the resolution was there. Yes, that's right. Mm-hmm.
Yeah.
So for taking possible. That photo, the photo of a black hole. Okay.
conceivable. Right. So it's interesting if you look at the Nobel Prize announcement for this prize, they say about Roger Penrose for his contribution to understanding black holes, and they explicitly say that. But for Angier, Ghez, and Genzel, when they're talking about the supermassive black hole, they don't name it. They say for their discoveries of a compact object at the center of the galaxy.
They won't call it a black hole.
They won't call it a black hole. Oh. Yo, let me just say, that's racist.
That's Chuck.
Yo, that's some racist stuff I haven't heard of. All right? That's all I'm saying.
You are
that
crazy.
Ain't right. That ain't right.
If anything has a tinge of it, Chuck is all up in it. He's going to call it out. Okay, thank you, Chuck, for calling out the racist ways of the Nobel Prize Committee.
The interesting reason why I suspect they did that is because, so they're looking at these orbits of these stars, right, around this dark object that we know is really heavy and really small, and by rights we should call a black hole. But it doesn't come near the event horizon. Doesn't come all the way close. So I think the closest approach of the star is about a few times as close as Neptune comes to the sun. And that's very, very close when you're talking about an object 4 million times the mass of the sun. But if it's only 17 times as wide, it's not that close. Mm-hmm. You know what I mean?
Right.
Whereas Event Horizon Telescope is seeing stuff like right on it.
Okay, so Chuck, if they gave it to the Event Horizon Telescope and still didn't call it a black hole, then you'll have good argument.
Then I got a case, right?
You got a case. We'll take that to the Supreme Court.
Now we got a case. We're going to take that. Okay, cool.
By the way, one thing about the Event Horizon Telescope image. First of all, a zillion people participated in that, so they probably have to give the Nobel Prize organizationally.
That's really
I would
interesting.
Bet.
Yeah, question.
Yeah, it's a reminder that today consortia make discoveries more so than individuals.
Yeah, for LIGO they gave it to 3 individuals, and
because they were at it long. They were at it long before LIGO was even LIGO.
Exactly, they were at it for 30, 40 years.
Right.
Before other people joined, and so that was different. But some people also argue that it should be given a Nobel Peace Prize because here you have an international consortium that transcends, all these nationalities, all of these political borders, all of these languages, all of these cultural differences, and come together and then give the work freely. Then the work is free. They don't even monetize it.
Right.
So that's an interesting argument.
It's a form of peace. That's exactly right. And a form of peace that scientists have known ever since the beginning as collaborations take us international.
Yeah.
I have a quick Event Horizon photo story. So I used the Event Horizon photo for a tweet. Can I tell you what that tweet was? It was, okay. So scientists, we've imaged a black hole in a galaxy, in the nucleus of a galaxy 55 million light years away. That's scientific. Public, right. Scientists, humans are causing global warming. Public, that doesn't agree with my philosophy. I don't agree with that.
Excellent.
How did that go down?
It was, people... It's social media, so it goes every which way. But
every which way it can.
But the irony wasn't lost on most people. So
it's funny.
That's brilliant. That's a brilliant tweet.
Yeah. And, so Chuck, so give it to me.
All right, let's get to it. Okay, so actually, we're going to start with a Patreon question from my son because I actually am on Patreon, so he gets to ask, which is, can black holes tell us anything about the age of nearby stars or stars that are orbiting them?
Interesting. Am I trying it or are you trying it, Neil?
I'll try, and if I miss anything, you jump in.
Yeah, because I think there's a lot of dimensions to the answer.
Well, so a black hole as the endpoint of a star, of a dead star, that star didn't live very long. Maybe 500,000 years tops. So if you see a black hole, if it's freshly made, then the thing that made the black hole itself was not all that old. 500,000 is not long in the history of the universe.
Not at all.
So black holes are the product of very high mass stars that have very short lives. But once you make the black hole, it's there, right? So you'd have to have seen the black hole get made to then know how young it is. But if the black hole is just hanging out, I don't know that you can know how old it is just by observe. Now, we know there's an upper limit to how massive a black hole can get as the endpoint of a dying star. But if you find a black hole that's much more massive than that, then stuff happened after that. Or some other phenomenon went on that would have kept accumulating, kept eating. And as it eats, it gets bigger and bigger and bigger. So I don't know that you can know precisely the age of a black hole, but you can get a sense of how long a black hole's been in town.
Yeah, I'm going to agree with you. I'm going to say even more so. One of the big mysteries about the supermassive black holes that were acknowledged, although not by name, in this year's Nobel Prize was that they're so big. And we definitely know those do not form as the end state of stellar collapse. Something had to happen to make that thing so big. So either it formed in the early universe, and this is something that's really odd. The bigger the black hole, the less dense the material you need to make it. It's very surprising. So you can make a really big black hole out of the density of air under the right conditions, which really surprises people. But if you make it from a star, it's got to be incredibly dense. So it could be that it was made in the early universe and not from stars at all. Or it could be that it started as a smaller black hole and then went through a bunch of collisions and got bigger and collected other black holes and just amassed until it was this supermassive black hole at the center of the galaxy. And that requires a lot of time and a lot of collisions.
Yeah. And just to round this out, currently none of us in my field doubt the likelihood that every single large galaxy has a supermassive black hole in its core. Initially, it was hypothesized, and then we had some early Hubble data, and then some other data, and then it was like, this looks pretty endemic to what it is to be a galaxy at all. And if you have colliding galaxies that merge, you'd expect the black holes to ultimately merge in the middle. So I got you on that one. But also, it's still, I don't know, I haven't seen the latest in this, but when I last looked, there was still some uncertainty about whether the black hole nucleated the formation of a galaxy, or whether the galaxy had mechanisms that funneled material to the center to then make the galaxy. Because even if you have a billion solar mass black hole, which some galaxies do in their center, that is it's less than 0.1% of the mass of the whole galaxy. So as ferocious as that sounds, the total galaxy wins. If you're on a balancing scale.
Absolutely. So you might have thought, even if it's true that all of these galaxies have these supermassive black holes, they're such a small percentage in terms of the mass, they're probably not influential on the galaxy. Who cares? Right. But it actually turns out that's not the case because they can blow these gigantic winds. They could have been very active in their early history and been like quasars. They could have sculpted the entire galaxy. They could have regulated the size, the shape, the number of stars that form. So they might actually have incredible agency despite their smaller fraction in terms of mass.
And is that because in the formation of the black hole that it is spewing out materials in order for it to become what it becomes?
In the early days, it was blowing out these jets, and it was like, imagine these winds. There are black holes whose jets are so strong that they're puncturing neighboring galaxies and basically wiping out any planetary life in those galaxies. So they have.
The galaxies just get into a fight. That's all. You're not understanding the dynamics of this.
So the Nobel for exoplanets is in a fight for the Nobel over supermassive black hole.
But the point is, you only get to see all this if there's material in the vicinity of a black hole for it to do that to. If a black hole completely ate everything in its vicinity, then all these mechanisms shut off. Then there's nothing to see. Right.
Wow. God, that's so cool. All right.
All right. Keep it coming, Chuck.
Here we go. This is Liam Pendergrass, also from Patreon. What opportunities for future research into black holes are created as a result of this particular prize being awarded? So is there anything new that came out of this that may spur further discovery?
Let me lead something here, and then I'm going to hand off to Janna. Because the Nobel Prize is essentially always delayed from the discovery itself, it's not clear whether the prize itself is stimulating more research, because the original research already did that, right? So the original research was already we already knew it was important. And the best kind of prize is the one that affirms what you already knew. And in this case, like Janna said, we knew Roger Penrose was brilliant. We knew he had influential papers. We knew the supermassive black holes in the centers of galaxies. That's a long-standing project. So that did trigger other interesting projects. Let's look at other galaxies to see if they have supermassive black holes with the next most powerful telescope. But Janna, do you think the act of getting a prize itself changes any of that landscape?
Gosh, I think I'm with you. I don't think the act of getting the prize does. I think it might affect generations that are just on the rise. Like, your son, Chuck, asked a question inspired because we were talking about the Nobel Prize. And who knows, maybe that's going to affect your son's interest
Very good point.
ultimately in science. I mean, for the scientists who are practicing now, I would say no, not so much. But it does have that effect, I think, for the younger generation.
Excellent point, because it's black holes are in the news now for a whole other reason.
Yeah.
There's a celebration with a big fat check associated.
Yeah.
Because in America, money talks. That's what it is.
Well, I'm glad to hear you say that, because that's for his research club. Black holes are his focus. So I'm gonna ask you.
Adorable.
I'm gonna ask you to talk to him.
And by the way, kids love black holes.
I don't care. We're totally cheating.
That
Screw
is
them
so
other kids.
cute.
Screw them other kids. I'll be like, my son has Neil deGrasse Tyson and Janna Levin. I don't give a damn. Okay? Sorry, kids. Sorry.
That's how the cookies crumble.
That's how the cookies crumble. What can we say?
Totally.
Wait. So, but it make an interesting point, Janna, that if it's another reason to talk about something in the context of it having been a celebrated result rather than just a highly respected result, that definitely adds a societal force on this. I agree with you there entirely.
And it's interesting that a lot of these Nobel Prizes are connected. So, for instance, the supermassive black hole at the center of the galaxy also has littler black holes orbiting it. And they did form from the end state of gravitational collapse. Now, littler might be 30, 60 times the mass of the sun. And so LIGO, which is the experiment that you mentioned earlier, Neil, that got the Nobel Prize, what was it, 2017, they're detecting the collision of two black holes that are more around 50, 60 times the mass of the sun each. And they might be doing that near a supermassive black hole. And so these are all connected discoveries. And so some of the ones that LIGO is beginning to, and I don't want to say observe, but really listen to, because LIGO doesn't take pictures. LIGO listens to the resonance of space around these like orbiting mallets. We're starting to think that maybe those in fact really are coming from galactic centers. So there could be 20,000, 40,000 black holes around the center of our own galaxy that are just smaller ones.
Wow. That's pretty. Well, all I can say to that is, there goes the neighborhood.
Black holes coming in. And they're gathering and becoming bigger.
They're going to destroy your neighborhood. I'm letting you know this.
And they get together and they get bigger.
Coming in.
And they're getting bigger. So, Chuck, we just blew that whole segment on your son's question. I just want to...
Oh, well, totally worth it.
Okay, so when we come back, we're picking up Star Talk Cosmic Queries with Janna Levin. We're talking about black holes.
So you're ready to earn your degree, but you need a university that works with your schedule. Well, WGU and their programs are built to be flexible. WGU offers a quality degree program that's affordable and even makes it possible to graduate faster. Plus, you can earn a respected bachelor's or master's degree for under $8,700 per year, fees included. That's right, you heard me. That is the correct, $8,700 per year. Let your experience and dedication help you earn your degree faster. See what WGU's competency-based programs can offer you. With no set login times and 24/7 access to most coursework, you can really earn a respected bachelor's or master's degree on your own schedule. The low tuition rate covers as many courses as you can complete each term. That means the faster you learn, the more you'll save. Get your $65 application fee waived at wgu.edu/StarTalk. That's wgu.edu/StarTalk for your $65 application fee. Poof, gone, waived. With Masterclass, you can learn from the world's best minds anytime, anywhere, at your own pace. Learn how to ace your opponent from Serena. Improve your writing skills with Neil Gaiman. Learn how to negotiate with Chris Voss. All right. Those were the courses I chose, but you'll have over 90 classes to make your own choice, and they're all taught by world-class instructors. Now, of course, the master instructor, Dr. Neil Degrasse Tyson, has a masterclass of his own on scientific thinking and communication, and we all know how important that is in these times. I'm not the only one who's benefiting from my masterclass. My brother is an avid tennis player, and I sent him the gift of a subscription so he could get schooled by Serena. Did I tell him that it was a part of my subscription? Well, let's just say the answer rhymes with ho, ho, ho. From learning how to write anything from a book to a screenplay to communicating with your boss to how to make dinner worthy of a Michelin star or just the best scrambled eggs this side of a jumpy chicken, there's a master class for you. I'm in the middle of a course on sex and communication because I'm good at one of those things. Masterclass is accessible on your phone, web, or smart TV. You can get an annual membership to Masterclass and give one to someone else for free. Get unlimited access to every Masterclass for you and a friend right now. Just go to masterclass.com/StarTalkRadio. That's masterclass.com/StarTalkRadio. You know, there are few things as satisfying as bringing a creation to life. And with Glowforge, you'll feel like a 3D laser printing Michelangelo as you use your Glowforge to cut and engrave a world of materials like wood, metal, glass, leather, and so many more. And because you can start with finished materials, it only takes seconds for the laser to create something ready for you to show off or sell. Create and make just about anything, and you don't have to be an engineer to design beautiful objects thanks to the easy-to-use Glowforge software. And I'm speaking from experience. Check out our YouTube Star Talk explainer videos on wormholes and the Mobius strip to see my 3D laser print of both. Yes, I was able to print a precision version of a wormhole and a Mobius strip utilizing a design Glowforge calls the Living Hinge that brought my material to life. I am so hooked. Everything I see, I think, how will I Glowforge that? So far, I've etched pictures into glass, printed a unicorn for my daughter, personalized some gifts with engraving. I love this thing. You'll love it too. You can bring home your own Glowforge with the absolute best price Glowforge offers. Get $500 off your Glowforge Pro when you go to glowforge.com/StarTalk. That's glowforge.com/StarTalk. And you can thank me with a 3D laser print. What shall it be?
We're back. Star Talk, Cosmic Queries. Chuck Nice with me always.
Always a pleasure.
And you're tweeting at Chuck Nice Comic.
Thank you. Yes, I am, sir.
And we're talking black holes today, so of course that means Janna Levin is in the house.
Yes.
And Janna, you're tweeting at what?
Janna Levin.
At Janna Levin. And it's a Janna with two N's. We got you.
Yeah.
All right.
I like an extra consonant, just in case I lose one, in case one drops off.
Janna Levin has three N's in it, just to let the record show. Yeah.
That's funny.
Yeah, what is it, 40% of the letters in your name? So this is Cosmic Queries. So Chuck, keep coming at us with these questions.
All right, I'm staying with
this one is from your wife now, right? You're the whole family. Okay. All right, go.
That will be fun. So this one is from Grandma Eugenio Barno. This is Eugenio Barrera. Says, hey, Chuck, Neil, Janna, how are you? After years of following you guys on YouTube, I finally pulled the trigger on being a Patreon, and I'm glad I did because now I get my question read.
Excellent.
Yeah. And he says, I was wondering if black holes have the gravitational pull to affect light, does it also alter its speed? So it bends light. Does it slow it down when it bends it?
So interesting.
Interesting question.
Neil, what do you think? Going to try this one?
I would just say no. Okay, next question.
But there's a really subtle example that I think illustrates how bizarre it is.
Okay, yeah, go for it, Jen.
So because the event horizon is by definition the place at which light cannot escape, you could ask, well, what happens to light at the event horizon then if it can't escape? And so you could just drop a little beam of light, a little bundle of light, and let's call it a photon, and it would sit there at the event horizon. It would not move. It's actually a completely not stable, unstable, but a place where it can be. However, you can't sit there and not move. So if you're falling across the black hole event horizon and you fall past that little piece of light, you go, oh, it's moving at the speed of light. But nobody can say it's not, because nobody could stay there with it, because you'd have to be traveling at the speed of light to stay there with it. So
Chuck,
when you fall into the event horizon,
Janna
it
in
looks
Wonderland.
to you.
Janna in Wonderland.
Let
Not
me tell
Alice
you
in
something.
Wonderland. It's Janna in Wonderland.
That is a rabbit black hole if I ever heard
Keep going.
one,
Keep
man.
going, Janna. Keep going.
Well, the other way to think about it is it's like a salmon swimming up the Niagara, like swimming upstream, and the waterfall of space-time is just falling in so rapidly that it effectively stands still. But nobody can stand still with it. Everybody else is going with the waterfall.
Right,
so everyone else, if they try to measure the speed of light, is like, oh yeah, it's traveling at the speed of light. It's nearly 300,000 kilometers a second. Nobody says it's standing still. But technically, it's sitting right there at the event horizon.
But it's still trying to get out. It's still trying to get out.
It's trying like hell to get out.
Okay.
But that is so
like
freaky.
hell to get out.
Yeah, that's freaky.
So what's the observation outside of the black hole? What are we seeing? Is it just
you
sitting
just
there?
don't see that photon because it never gets to you. When you say, what do I see? The only way you see something is if the light hits your eye.
Right.
So
But you can't do it because it's stuck there.
So you don't see it.
Oh my God.
So it's dark. So the event horizon's dark. It's a black hole.
That's crazy.
Wait, and another, just to add another point there. Right. You will only see that photon if that photon enters your eye. Right. So therefore you have no idea it's even there. This was my issue with Star Trek. Right. They have these phasers that phasers, right? When it shoots lasers at another ship. Okay.
Yeah,
in the vacuum of space.
Those are phasers.
Yeah.
And then they have photon torpedoes.
So they're sending this in a direction towards the ship. But the camera view is from the side. So
but you see this like...
You see it. There's no. It's sending this energy to the ship. There's no way you would see that laser going to the ship.
Right.
There's just no way. Unless it's sending light in your direction, but that wouldn't be an efficient weapon.
Or
so I
like
had
you
issues.
or you make like a gas cloud and it scatters.
Oh, yeah. Okay.
So you can make like a fog chamber. You
No.
You have a fog machine.
You hit the chalkboard erasers together, and then you make
right.
All right, Chuck, give me some more.
All right.
We now know Janna is a cousin of Alice in Wonderland. Yes.
Okay. This is from Bishivi. Cool.
We'll go with that.
I'm going to go with it. I'm going with that. Says, what did Roger Penrose do that wasn't already done by Einstein and Schwarzschild before? A little bit of a hater here. A little bit of a hater.
So I think, Janna, you hinted to some of that. Yeah. But why wasn't Einstein's solution or the Schwarzschild solution inevitable? What is the different thing that Penrose did to make it a natural end state?
Mm-hmm. Well, so in the simplest terms, he was able to show that generically, without assuming any special properties, like something's a perfect sphere. It could have been an oblong, kidney-shaped eggplant thing, doesn't matter. If it collapses, he was able to prove it would inevitably form that event horizon, and within that event horizon, inevitably would be the singularity. And one way to think about this, which I think is really profound, is he was able to show that all paths of light, and this is technically one of the ways that he did it, point towards the singularity. Technically, what that means is that the singularity is in the future. We look at a black hole, we think of a spherical thing with a center point that's this point singularity in space. What Roger Penrose showed is the singularity is not in space, it's in the future once you're inside that black hole. And so nobody who enters the black hole can do anything but plunge into that singularity. You can no more avoid the singularity than you can avoid the next moment in time.
Okay, so wow, that's
like I said, Alice in Wonderland. There it is. That's what, like I said.
Dad, go on.
Yeah.
Give me a second. I'm gonna go pour myself a little vodka, and we're gonna come back and talk about this.
We're definitely missing some mind-altering forces.
Wow.
Wait, so Janna,
we're going to have our after party Zoom link. Yeah.
Wait, so Janna, just to if I understand what you're saying, if all light beams go to the singularity, then all possible paths into your future as you fall in would go to that singularity, because you can't take a path that's not the path that the light takes.
That's right. So basically what it says is it basically says if you're going slower than the speed of light, you are definitely going into that singularity, because the only way you could not go into that singularity is if you went faster than the speed of light, and you can't do that.
Okay.
Right.
So the technical language would be, just because it's sometimes poetic to hear it, it's not necessarily edifying, but it's poetic, is that he proved that all of the future light cones pointed towards the singularity. That's what he showed. There's one figure in this paper in 1964 where he draws it all out. I'm telling you, it's just the most beautiful. It's all compact. It's all right there in this one picture, where he just shows that this absolutely is inevitable, that the black hole singularity forms, and that it is in the future of any path on the interior of the black hole. Yeah.
All right. Chuck, keep it coming.
Okay. All right. This is Izzy Rohr. Says, hi, Neil, Chuck, Janna, it's Violetta, my mom, Izzy. I'm 12 years old from Birmingham, Alabama, and I love all things astrophysical. Professor Gez says that the data collected, which ultimately proved the existence of Sagittarius A, are consistent with Einstein's general theory of relativity, while absolutely 100% not consistent with Newton's law of gravity. And even then, she said that Einstein is right, at least for now. My questions are, how can something, a major thing like this in the cosmos, abide by general relativity and yet not follow one of the most basic and fundamental laws of physics? Does this mean we will need to discover a new law of gravity? And does this mean general relativity needs to be upgraded or expanded upon? P.S. Janna, you are the first woman astrophysicist I ever saw in an episode of Star Talk a few years back, and you have inspired me so much ever since. Thank you for rocking science so hard for girls and kids like me all over the cosmos.
Go, Janna!
Thank you.
Go, Janna!
Thank you.
And by the way, none of that question impressed me like the way the question began, because she knew that the word data is plural.
Plural.
These data show what these data are. Yeah. So if you know that, you're ready for any kind of scientific career.
Well, I was so flattered and flushed that I forgot the question. Oh, but I think I got it. It's actually...
I think it's if it violates Newton's laws, how's that possible? If Newton's laws apply across the universe, but it satisfies Einstein's laws, what's going on?
So I liken it this way: just because Newton's laws aren't all encompassing doesn't mean the laws are like wrong. They're not dead wrong. And I sometimes try to explain it this way: if you thought English was the only language in the universe, and then you discovered there was this broader concept called language, it wouldn't make English wrong. Right? English is useful. It just has a limited range of validity. It doesn't help you with French or Arabic or whatever other language. It turns out that there are extensions that's a much bigger umbrella, which is this concept of language. Right. So to a certain extent, in its limited range of validity, Newtonian physics is great. Works terrific. It just doesn't work everywhere all the time. It's not big enough. It's not that it's wrong. It's just a subset of a larger concept. So the first thing that Einstein did when he was trying to test his own theory was exactly to make sure he respected Newton, that he respected Newtonian dynamics in its range of validity, which would be when you're not moving very quickly, when you're around big things like the Earth, when you're moving slowly, like it should look like Newton said it should. So So it's not as though when I drop an apple, it no longer does what I used to think it does just because of general relativity.
So so what you're also saying there is that if you take Einstein's equations and put in low gravity and low speeds, they become Newton's equations.
That's right. They become very close approximations to Newton's equations.
Yeah.
Exactly.
Okay, so they're still in the same sandbox. Or the sandbox is bigger now.
Yeah. The sandbox just got, Newton never considered, well, what happens if I crush the Earth to a point? Or what happened if I was going near the speed of light?
Yeah, they're stupid.
And those were exactly the kind of thoughts experiments, the kind of fantasies that led Einstein to realize that, Newtonian mechanics would slowly look different than we presume it is. And we would start to learn that there are generalizations that start to look very different in certain extreme circumstances.
All right, Chuck, we only have like a couple of minutes left. See if we can squeeze 2 in here. And Janna, soundbite answers. Okay, go.
Okay.
Chuck.
All right, here we go. Cameron Bishop says singularities or ringularities. I just got to know what we know about the geometry at the center of a black hole.
Yeah, what's a ringularity, Janna?
Oh, in a spinning black hole, it turns out that the singularity has a different geometry than it does in what Schwarzschild considered, which was just kind of a perfect implosion. But I think that...
Is it a donut?
And wouldn't most black holes then be spinning black holes?
Yes, most black holes are spinning black holes. Yeah, absolutely. And when things collapse, just like an ice skater pulling in her arms, they tend to spin faster and faster. So we do believe that black holes are likely spinning. But most, to be honest, most astrophysicists and theoretical physicists believe that the singularity is where general relativity will break down, kind of connected to your previous question. We believe that there's another theory that will make us understand that singularities actually don't exist. And that they're telling us, this isn't working anymore. This is breaking down.
As has been said, the singularity is where God is dividing by 0. Which is, that's a no-no.
No, seriously, you're now going to have a cult. You can't say stuff like that. It's going to be in QAnon. QAnon.
Come to where God divides by 0.
On November 3rd. God is dividing by 0.
All right, another one, quick, Chuck, give it to me.
All right, very quickly. This is Sam Axe. Sam says this. If you were to throw some antimatter into a black hole, would that shrink it or make it bigger?
So a lot of people have the misconception that antimatter has negative energy or negative mass, but it doesn't. There's really, not to our knowledge, anything with negative mass. So if you have an electron, its antiparticle has opposite every other quantum number. For instance, if the electron's negatively charged, the positron's positively charged, but they both have the same mass. So mass and energy is what matters when it goes into a black hole. You might change the charge of the black hole, but you're just going to make its mass go up. It's going to get heavier.
Okay. So antimatter is not some panacea for undoing the universe and the damage that gravity has done.
Right.
Guys, I think we got to call it quits there. We're out of time. Man, damn.
Oh, man.
That was awesome.
Always so good. It's always so good with Janna Levin.
Janna,
I miss you guys.
I hear rumors that you're working on another book. This is rumors. I'm just saying.
I am.
Just rumors. But okay, when the book comes out, can we bring it back?
Yeah. Black Hole Survival Guide.
Oh, we need that. Well, we got to bring it back for that.
Yeah.
Can we bring it back?
I'd love that.
Okay, we'll talk
Always
about your
fun.
book. And we'll bring it back soon. I think your book is coming out even just in a few weeks.
Yeah.
So, all right, Chuck, always good to have you.
Always a pleasure.
Janna, we love you here at Star Talk, and thanks for always accepting our invitations. All right.
Always.
This has been Star Talk, Cosmic Queries, the Black Hole Nobel Prize edition, of course, with Janna Levin. I'm Neil deGrasse Tyson, your personal astrophysicist. Keep looking up.
With Masterclass, you can learn from the world's best minds anytime, anywhere, at your own pace. Learn how to ace your opponent from Serena. Improve your writing skills with Neil Gaiman. Learn how to negotiate with Chris Voss. All right, those were the courses I chose, but you'll have over 90 classes to make your own choice, and they're all taught by world-class instructors. Now, of course, the master instructor Dr. Neil deGrasse Tyson, has a masterclass of his own on scientific thinking and communication, and we all know how important that is in these times. I'm not the only one who's benefiting from my masterclass. My brother is an avid tennis player, and I sent him the gift of a subscription so he could get schooled by Serena. Did I tell him that it was a part of my subscription? Well, let's just say the answer rhymes with ho, ho, ho. From learning how to write anything from a book to a screenplay, to communicating with your boss, to how to make dinner worthy of a Michelin star or just the best scrambled eggs this side of a jumpy chicken, there's a master class for you. I'm in the middle of a course on sex and communication because I'm good at one of those things. Masterclass is accessible on your phone, web, or smart TV. You can get an annual membership to Masterclass and give one to someone else for free. Get unlimited access to every Masterclass for you and a friend right now. Just go to masterclass.com/StarTalkRadio. That's masterclass.com/StarTalkRadio.